Ohio. Welcome back, everybody. It's been a few days since I've been able to stream. Worked some late nights at my job recently, but now it's the weekend, so we can do whatever we want now at this point. So, where do we stand? So last time, I just goofed around with the makefile and crap. It wasn't all that interesting. But now, things are organized a little bit nicer. Maybe. And we can adjust as time goes on. But anyway, so everything builds. Still, you know, all is well and good. So now we need to tackle a rather big thing that I've been putting off for quite a while up to this point. the concept of paging. Paging is dividing physical memory into what's called virtual memory. So the physical memory is the actual memory that exists in RAM. So in regular old x86, you have up to 4 gigabytes of physical memory. And you can do stuff in different portions of it. So paging is the concept of taking that physical memory and chunking it up into smaller pieces that are called frames. And then mapping each of those frames to a different address. So if you have 1 gigabyte of RAM, for example, you could section that into four frames, and then map each one of those frames back to the first beginning of memory. So each little piece of memory would think that it's at the beginning of memory. So the first 4 megabytes or whatever, or 250 megabytes would be at 0 to 250, would be from addresses 0 up to 250 megabytes. Then the second 250 to 500 megabytes could be mapped to think that it's 0 to 250. So that way you can write programs that always think they're in the same place of memory, so it's easier to write for. If I understand correctly. So I guess we're just going to jump right into this, I suppose. Let me open the OS Dev wiki page on it. So these chunks have to be in at least 4 kilobyte blocks. So I've already done something really similar with the heap. By using a linked list. Just out of curiosity, can I move that back one? So basically, I can do something really, really similar. Whereas with the heap, I have, a starting location, and I have a maximum size defined. But with those, I can section off arbitrarily small, down to 64 bytes. So to do something similar, only with an exact size of 4 kilobytes. So maybe what I need to do is because I'm basically going to reuse a lot of this heap code. So maybe I should make a new type def for a linked list, because the heap uses a linked list, but it's just kind of implemented right there as is. So maybe I should instead make a type or a class, a linked list class. So that way I can use it in multiple ways. Or I can just hard code it all again for right now, just to get it working. So the cool thing about the paging, though, the page table, is that it can be simpler because we won't have to worry about merging blocks because there will only ever be 4 kilobyte size blocks no matter what. But we can still treat it the same way. So like as you allocate pages, you move out into this memory space that's been defined. But as you don't need pages anymore, you can just mark them as free, and the next thing to come along that needs a page can just take one that's already taken. So there isn't really a need to destroy pages. So maybe instead what we should go ahead and do is just pick our memory space that we want our pages to be in, and then just allocate them all. Because we know what size they're going to be all the time. And I might be going about this completely wrong. Here's the documentation. So this is what the page directory entry looks like. And each one of these points to a page table. And then the page table, depending on where the page table entry is in the table, the first entry will represent the memory location 0 to 4 kilobytes. And then the next section is the 4 kilobytes to 8 kilobytes. So depending on where you put an entry with a physical address in the table, it'll map it to that location. So if I put, if I were to make an entry for memory address 0, just to say, I would probably not do that, and then put that entry in spot number 10 in the page table, then the address of 0 would then be instead mapped to 10 times 4 kilobytes because it's in the 10th spot. Fortunately, those are just 4-byte entries, so those are just integers. So you can have up to 1024 page directory entries. And in each page table, you can have 1024 entries. So you can have that many different mappings. I have no idea how this is going to work, to be honest, but we can give it a try. So we can do something really similar, like we did with the heap. Let me just make some files, I suppose. So I guess for right now, we'll just put it at the top level. So we'll do ending kernel. That. Oh, include define. that. Hey, Mom. Include. Oh. Include. There we go. What do you mean you're not detected? Yes, you are. Oh, okay. Good. There we go. Okay. So what do I want to do here? So we'll have to do something very similar like we did with the heap, where we'll have a little header at the top of every page to denote whether or not it is being used currently. Right? Look back at our documentation here. Yeah. There we go. Music put me to sleep. Make it more interesting. So there needs to be one universal page. No, there doesn't actually. So there doesn't necessarily need to be a universal page directory. I think you could do individual page direct. What I'm trying to get to eventually is to the point where we could create like processes and threads and all that stuff and be able to run other programs. Hey, Omobu. That's what I'm thinking, page directory. So there'll just have to be a place where we keep track of all the page directories too. And the page directories are just, I guess we'll just have to make like a master page directory kind of thing. Because the page directory is just a bunch of 4-byte entries. Yeah, I suppose. Just trying to think about how a hash map. I'm actually really unfamiliar with those, to be honest. I'd have to implement a hash map then. By a combination of key values and map values. I mean, I suppose the term I'm more familiar with is dictionary. What would the key be then? Would the key be like the name of the process that owns it or something, or? Something unique. Maybe I could use like a... Depends on the memory allocator. Well, I have one already. I have one working already. Yeah, so I can make stuff on the fly now because the memory allocator is working allegedly. What if I use what if I made it like a union? Would that be an okay way to save values on top of each other? A union with an address and a byte or char array to hold the name, so you could read out either one. No? I thought a union was like it's basically giving the same spot in memory just different names or different ways of accessing it. So you could like do a union that's an integer and an array of 4 bytes. You could access it as an integer, or you can only hold one value at a time. Oh. Oh, I see. Oh, yeah, it's the same data. You're right. That wouldn't work. Yeah, that doesn't make any sense. Yeah, hash map class. Yeah, maybe you're right. Yeah, maybe I should go ahead and try and do a hash map class first. Unordered map. Unordered map. Here we go. Who said it needs to be robust? For right now. Yeah, you're probably right. As associated data contains key value pairs of unique keys. Search insertion. How are they? Are they generally? Is it common to make classes that inherit from a hash map so you can make whatever kind of data you want go inside them? Template, okay. How do you decide, like, how do you make a hash map of the type of data that you want, though? Like, what if you want it to map to, like, a struct of some kind, or integers or whatever? How do you... Oh. Is that what those are? Ah. I see. So you use a string as your key. foo as a value. Oh, so you can just turn anything into an unordered map if you want to then. That looks complicated. A hash function being what turns your key into, or what finds your value based on your key. Oh, I see. Yeah, the actual... I learned about all this a long time ago, but have never really used it. Yeah, don't worry about trying to explain it now. It's Well, maybe I can start from the bottom down for right now then. Start with the page table. Where's my... For ints. Simple as return X. Oh. Use your key, look up the value, and just return it. Oh, is that a rule? Really? That data. I'll have to do some more research on that. But I want to make some progress, so start from the bottom. Start with a page table entry. I just... First, I need to be able to create table entries, which I don't think will be that hard, because it's just 4 bytes, which is an integer. And it just contains, each one just contains this, stuff. So it should just be as easy as making a nice little function that takes in all the parameters you want and just sliding them across to the right location, and then just return that number out, and then we can just save it somewhere. So that should not be that hard. So we'll start off with, these are 4 bytes, so they're going to return integers. So create page table int. Can I have it? So the address that we want it to be at, and then all these funny little... Oh. Like with a struct, actually. For everything. Oh, and then just return it out as an integer. Put it and then piece it together and return it out as an integer so it can be made into an entry. That's a good idea. That's a good idea. I like that idea. Good idea. Okay. That's reasonable. Class. What'd you say? Unpacked? That's a good idea. That's a good name. Unpacked page table entry. Public, private, unpacked table entry. So just right now. Okay. So all its private data will be the... Can I just have a void pointer? Page address. So we're looking at this one here. So this is the page. The page table is the lowest level one. So we have this physical address portion here. These 3 bits right here are available. And so because that's only... The rest of these could probably all just be chars and booleans because they're technically 1 bit. But in a class, they'll take up 8 bits. So that should be fine. Unsigned char extra. Oh wait, I always like to do this. You know what? Here, I'll let me comment this crap. So it's 12 through 31. 9 through 11. I'm just gonna make these bools because the rest of these are unsigned bool. So bool, 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 dirty, bool, accessed, bool, cache, disabled. Beginning to not like this keyboard. Bool right through bool yeah, I mean, it feels really nice. It's the one that came with my machine, so it's like, it's definitely mechanical, but it's not my favorite type. I like really clicky keyboards. And the keys are in kind of a weird shape. Like the enter key is like the enter key is not like a bar, it's more like a dog leg kind of thing. So I keep missing it. So bool privilege level. User gosh, supervisor, bool, read, write, bool, present. Like that, okay. So I guess we should, in our, I guess in our constructor, we want to go ahead and take all this crap in. So void pointer adder. Oops. Dirty bool accessed bool cache bool right through bool privilege bool read write bool gosh present. All right, so get rid of all that. So then we want to return this out as entry. So we can do an int return as table entry, like that. So that will mush all that crap together into one integer to pass out to us, so we can put it into the table. Is there a reason we'd want to turn an integer into a table? No, we want to create it this way first. So we just create them like this with, and then just get them out. Like this. Right? Turn an integer into an object. Well, I mean, that's what I'm saying. Like, would it ever... Would I ever create the data for this manually and then want to shove it into one of these? That's what I'm thinking. Like, if I just use this way to create all the data, every page, then I don't think there'd ever be a reason to want to turn an integer into one of these. I mean, maybe I could, you know, maybe I could go ahead and do a create the page you want. Oh, save memory. That's true. Why don't I just make another constructor that takes just an integer? Yeah, I'll make another, yeah. Unpacked page table int int form. Something like that. Yeah, that's good. Let me change this thing's name. I like rename. Unpacked page table entry. Good catch. Unsinged. Good catch. These are all... That's an unsigned chart, yeah. Okay. Good. That's good. So unpacked... Actually, this needs to be in my H file. Unpacked page table int. How's your day been going so far, Mobo? Not too bad? That's good. Got off not too long ago? Pretty good. Pretty good. I haven't got a chance to work on this in a while, actually, so I wanted to get some in this morning before I got some stuff I gotta do later today. I've been putting this off for too long, though. I need to... H. There we go. Unpack page. Okay. That looks reasonable. I think I need to go ahead and include basics. Otherwise, that's not going to build. Include... let's see. No, basics is just at the top. Isn't it? There we go. This system header thing makes it so much easier. I'm glad you guys helped me with that. Okay. So that's looking good. Now let's find some crap out here. Oh, you weren't there? Yeah. Yeah, it was a tweak to my make file. Hey, VK. Welcome. Welcome, welcome. Glad to have you. All right, so now we just need to do some fancy schmancy bit shifting crap. First. So these addresses have got to be aligned on 4 kilobytes because they're only, what is that, 12 to 31? Is that 11 bytes? Simple math, guys, simple math. 31 minus. Shift them bits, yep. That many bits long, yeah. Not a whole address. So should I leave it up to the user to make sure it's left aligned, or should I just go ahead and force it to the next should I just let them pop in an address? Well, me, I suppose. Should I just allow myself to pop in an address and just have it automatically do the math and put it at the next left aligned location? Because I want to make sure, I imagine I'll want to make sure that I'm not overwriting a page that already exists. Is there a way to escape a constructor? Like, because I don't want to... Well, no, this isn't actually keeping track of anything yet, so maybe I should go ahead and just let them do whatever they want to do. But like when I insert an entry into a table, I'll want to make sure that I'm not overlapping anything. But this is just translating or making it easier for me to create entries. So this really shouldn't do a lot of thinking, I imagine. Maybe. Well, the thing is, too, if I just save... Oh, well, I can kind of do it automatically. It'll automatically make it the next... It'll automatically turn the address into the next 4 kilobyte aligned area, because when I start shifting bits into it, it'll actually overwrite the rest of the address. So the part that's left over will be the 4 kilobyte aligned address. Yeah, that's kind of cool. So I want to do physical page address equals... Oh, well, if I want to save this, though, I want to go ahead and shift it, shouldn't I? So I want to do adder bitwise OR with, what's the, gotta remember my bit shifting syntax. Left and right shift operator, here we go. All right, so it's what you want to shift with however many left. So if I want to shift, how many bytes was that? 19. So 32 minus 19. 13 bits. So I want to do 0, 13. Right? Why not? What's wrong with that? Oh, I gotta make this a int. No? What's wrong with that? Must be integral or unscoped enum type. What do you mean I can't? What's wrong with that? Should I go and take this in as an int then, I suppose? If I make that an int. And maybe it'd be okay to go ahead and make this an int pointer too, because this is... You can treat this thing as an integer. So I think it'd be okay if I went ahead and just made this an int pointer. Because it's going to be pointing to an integer. So that's a safe thing to do. Must have an integral or unscoped enum type. What does that mean? What are you complaining about? What's wrong here? Oh, I'm just a little rusty on my bit shifting. Yeah, so I want to OR this with... Well, couldn't I just OR it with... F. I guess I could just OR it with OX. To that's a whole integer right there. I only want 4, 8, 12, 16, 17, 18, 19. I only want 3. Crud, hex in my head isn't working. Would it be like, and then the next 3? No, that's 16. 4, 8, 12, 16. It'd be like that. 1, 2, 3, 4. Not sure what this is telling me about. Expression must have integral or unscoped enum type. What does that mean? Integral or unscoped enum type. What does that mean? really confusing me here. Oh, I made that an int. Never mind. Oh. So let's do the how to align to 4 kilobytes. Check whether something is 4 kilobyte aligned. Nope, that's not what I want. Why is this not allowed? Do I need to... That doesn't make any sense. I can do that, can't I?
The universe is going to get awfully cold. We think the universe is headed for a big freeze.
What I'm trying to do is I'm trying to just I'm just trying to turn all I'm trying to turn bits 0 to 0 to 11 into, or yeah, bits 0 to 11 into zeros. That doesn't make any sense. It's not logical. I want it to be bitwise. 0 shifted over 11 times. Why can I not do this? What's the problem here? What if this was a real int? And just to see here, what if this... It allows that, so I can't do that to an address? Is it mad that I can't... Oh, what if I just cast it to a... And then, whatever, turn it back into an int pointer. Oops. Oh wait, no, it is an int pointer already, so... Okay, that's annoying, but whatever. Okay, so that there should zero out bits 0 to 11. And so that will give it, that will turn it into a 4 kilobyte aligned address. Right? Yeah. Okay. So, and then the rest are just the same. So, extra equals extra. Dirty equals equals dirty. Accessed equals accessed. Cache disable equals cache. through equals right through. Privilege equals privilege. Read write equals read write. I think that's it. Present. Like that. Do I really need to do this right here? I don't actually need to do that right there, I don't think. Yeah, I don't actually need to do that right there. That's kind of silly. Okay. But if I do... Unsigned. Let's make that unsigned. There we go. Unsigned. Unsigned all around. And so now this one will be if we just want to jam in an entry. Does bit shifting actually change the value permanently, or does it just do one calculation to see what the answer would be? I could just do OR logic, bitwise logic. Physical. Thanks for the follow, Humans PR. Appreciate it. So I could just do int form so I just need the first 11 bits. So 1, 2, 3, 4, 5, 6, 7, 8. That is a whole integer right there. So this is 4, 8. That, I think. No, that's not what I want. I want, no, that is correct. No, wait, hold on, hex. So, 4, 8, 9, 10, 11. No, I only want 1, 2, 4. 1, 2, 4, 8. that. And cast it to an int pointer. Unsigned int pointer. Line to 4 kilobytes. Okay. And then the rest of these are just, we want to just OR them. With the bytes that we want. So, extra equals int form ORed with, so shoot, what are the next couple of bytes? So 9, 10, and 11 are the only ones we want. So OX, so 4, 8, 12, 16, 34. Because there's the whole thing right there. So we only want 9, 10, and 11. So 4, 8, 9, 10, 11's 1, 3, 7. That. And let's cast it to a char so it'll fit. Like that, maybe? I have no idea if this is going to work. I'm not super well versed in my binary arithmetic. Okay. And global bool int form logical OR with. So then this one should be byte number 8. Yep, so we just want byte number 8, so 4, 8, so we just want the 8th byte of that, right? Or the 4th bit of that one, which would be 1, 2, 4. Yeah, which would be 8. And then dirty. So this one's just the next one, so we only care about the next byte, which is 4. Okay, I think I'm figuring this out here. Wait, is there a 0 byte in there? Did I miss something? Look right there. Did I miss something? Oh, this thing includes the other stuff that the page directory also has, so I didn't look at those. Dang it. Okay. There's also a size. size, accessed, cache disabled, write through user, read write present. What's that 0? I'm trying to figure out what this 0 byte is for right here. What does it talk about that? Let's make sure I got everything here. So the size is there. What? Go back in there. Thank you. So G for this one is ignored, but this doesn't. It says it down here. It looks like there's a zeroed out Boolean right there. So I guess I'll just put it in there. Well, this guy down here uses it, and that's what I'm using. So, pat is what's called. Not sure what that means, but so where'd those go? So after global, there was a bool size pat. Not sure what that means, but that's okay. Okay, so where were we? So we had global, we had size bool pat. Size equals size pat equals pat. Okay, whatever. Okay, so we gotta take these in too. So global, so size was in there somewhere. Oh, so size was the next one actually. So 8. So this one is no wait. 7. Yes, this one here, global. Global's 8. So the next one, this one here, dirty. This is size. I think pat is always going to equal 0. But since this is creating from one that was already previously created, it should already be formatted correctly, so we'll just go ahead and keep it. We'll just go ahead and not bother with making 0. We'll just go ahead and read it in anyway. OX. Pat, then dirty equals bool int 1, 2, 3, 4, 5, 6, 7, 8. Dirty access equals bool int form ORed with 1, 2, 3, 4, 5, 6, 7, 8. Right? One, 2, 3, 4, 5, 6. Wait. That's bit number 6. What did I go wrong? Man, binary math is confusing. I did something wrong. So extra is supposed to be bits 9, 10, and 11. Am I thinking about this the right way? Each one of these spots is 4 bits. Oh wait, this is in hex though, so each one can hold up to... Wait, I've got too many zeros. I did that totally wrong. I did that totally wrong. Hold on. So... binary. 1, 2, 3, 4, 5, 6, 7, 8. No, wait, that was right. So, yeah, so 8 hex spots is an integer. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I was right. I was right. Maybe we should use the calculator to do this. Let me go. Start over here. So, binary. No, and hex 700 is this. So 1, 2, 3, 8, 9, 10, 11. Yeah, so I was right. So byte number 8 being what I think it is, which is 80, which is this. That's number 8. That's correct. 40 is number 7. That's that weird size bit. Then the next one should be 20. That's 6 right there. 1, 2, 3, 4, 5. I'm confusing myself. I gotta start over here. So I know this one's right. I know global is right. 80. Should be bit number 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh wait, 0, 1. Zero indexing. Hold on. 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. I'm confusing myself here. One, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I went bits 10, 11, and 12 accidentally. So this should actually be... This should be E. I was wrong. It's in hex. E00 is this. So 8, 9, 10, 11, and 12. There we go. Ah, so I was one off. So now this guy here needs to be 7, 0. No. No, 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 no. 1. Because these 3 bits and then the next one here should be this one. So that should be in hex 100. The next bit right there. There we go. Then this guy should be 8. Because 80 is bit number 8. And that was size. So 1, 2, 3, 4, 5, 6, 7, 8. That's correct. There we go. This guy should be 4. This guy should be 2. This guy should be 1. That put me back on track? I think that puts me back on track now. So dirty is number 1, 2, 3, 4, 5, 6, 7. So 4. Wait, crap. Size is right here. It's 1, 2, 3, 4, 5, 6, 7, 8. And I already know that 80 will give me the 8th bit, which is right here. Then dirty Wait, why is this guy not... Oh, does this guy not have size? Oh, it's because I threw an extra thing in there. This guy doesn't have size. I got it mixed up. That's why I'm getting thrown off one. Yeah, we're dealing the page table entry, not the directory entry. So this guy should... So size needs to hop on out of there. 8, 4, 2. We don't need size. Get rid of size. Get rid of size. Get rid of size. Okay. Does that put me where I want to be? Alright, so pad, which is the 0 here, that needs to be 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So then dirty is bit number 7. So if I... 40. That's bit number 7. There we go. Now we're rocking and rolling. And then access is bit number 6, which should be 20. 1, 4, 5, 6. That's correct. And now, so cache disabled with that. That should be bit number 7. Right through equals bool. Ah, 1, 2, 3, 4, 5, 6, 7, 8. Nope. Yes. Right, because just 8 in hex gives me the 4th. One, 2, 3, 4, which is what I want. Yep, this is all good. Alright. I gotta figure it out. Gah. That took way longer than I expected to, though. 4, 2. 1. So, this one is priv. This one is read write. Present. Okay. So that will turn an integer into one of these. So I gotta do the same thing essentially, but backwards now with the unsigned, with the return as table entry. So I gotta do the same thing, essentially. I mean, I could just OR everything together. I could just do that, yeah. Int entry equals physical address ORed with extra or global or hat or dirty or accessed or cache disable or write through or priv or read write or present. Guess that's in it. Return entry. Members. Or everything together to make a single int table entry. Okay. Oops. Keep turning down the volume, my mistake. So that should be that for right now. This is kind of hairy, but that's okay. So this right here will automatically force it to be 4 kilobyte aligned because all those extra bits at the end of the address will be overwritten. Oh, do I need to cast these all as integers maybe? I should probably cast every single one of these as integers. Because all these are booleans and chars. Yeah, there we go. So that'll take all the fields and just jam them together into one integer. And return the table out. Actually, I feel like I should do this. No, I'm not going to do this here. I'll make the, when I make the function that creates new pages, I'll have it automatically pick pages that are at 4 kilobyte alignments. And so this thing doesn't have to worry about forcing it to be 4 kilobyte aligned because it will already be when it comes in. Yes. So unpack that table entry. Should I go ahead and do this the same thing for the unpack for the page directory, which is this one? Might as well go ahead and do the same thing, to be honest, if I'm already here. Okay, so I guess I'll just do the same thing because I'm already kind of around here. So we'll just do if and def. Impact page dir h file. Define unpacked. Okay. So we got that. So it'll mostly look like this. What did this replace? It looks really similar. It's got the global, the size is there, this pat's moved down 1. Caching is removed with this D. Oh, dirt. That's the dirty flag. Okay, so I guess let's make it look like this instead, so that we got the global, we got the size. It's just a Boolean though, which is kind of funny. The path, then we have the. I guess we'll go ahead and just put stuff in the correct order too. Access, dirty. Oh, cache disable. Oh, that's what that is. That's the cache disable. Got it. Right through. U is the privilege bit. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty sure that's it. Oops. So this is page unpacked. Page dir entry. Return as a dir entry. So what did we change here? So we got cache disable 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where'd the size go? So many variables. Present, read write, privilege, write through, cache disable, accessed. Oh, dirty's not there anymore. That's replaced with size. There we go. Okay, that should be that. So this will be all very similar. Back page dir. 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 As dir. So dirty doesn't exist anymore. So now we got to get the bytes back in order because the bytes are a little bit different. The order is just a teensy bit different here. So our physical address is the same, extra is the same, global is the same. So size is now the next one. So size, then pat, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 7. This is size. Size. So these are out of order too. Well, that actually doesn't matter because they're just going to get ordered. As long as they were read in the correct order, in the correct bits, then when we OR them all together, they'll be ORed back out in all the correct bits. So this should just be size. I hope anyway. Be right back. Hey, Real ABC. Thanks for the follow. Welcome to the channel. Okay. So I think that's my page directory and page table entries made appropriately. So now I just have to put them somewhere. Saving extra. This. That's not right. And two. Oh. It's coming in as an unsigned. You're right. Oh, do I want to shift it back then to not... I had it 7 to start with, but maybe my math got messed up. Hold on. So if I want to do... I think I had it to be being 7 to start with. Because it's physically, it's the 10th through 12th bit. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So in hex, E00 gives me 4, 8, 9, 10, 11, and 12. Whereas 7 would give me 9, 10, and 11. Right? I mean, that sounds right, doesn't it? I'm pretty sure that's right. Yeah, because just 700 would give me 9, 10, 11, and 12. Physical page address. Oh, you're right, because that's wrong. You're correct. This should be... 8 gives me... So, hold on. So, 1, 2, 4, 8. FFF00. Because of E, didn't it? Yep, you're right. You're right. I missed that one. And I gotta do that over here, too. Yeah, because I figured that out back when I thought it was still 7, but if I move over another bit, I gotta move that one up another bit, which then cancels out. Got it. Okay. So I think this will work, I think. Okay. So now I gotta come up with a place to put these stupid things. You need to shift... Oh, because it just doesn't fit in. I need to shift it back 8, don't I? Because the way it is now, I need to get rid of these bytes, right? Gosh. Cannot type. Should I be doing that for the rest of these two? Shift 9. Oh, you're right, to get that extra byte. That's what I thought. But yeah, you're right. So 9. Because I want just those 3 bits to represent a number. Byte math, man. You're right. I gotta put it back again. Yep, that makes sense. Casting everything to an int essentially just puts all of the extra zeros. Shift the bools when packing also. Oh, you're right. What if I save them as, do I want to save them as chars, though? I could save them all as ints to represent their... to preserve their location. I don't want to do that, though. Ah, yeah, you're right. I'll just have to shift them. But because they're all stored as ints, I just have to shift them over exactly however many spots that they need to go. So that's not that big a deal, really. Shift you back over. You are literally number 8. Yes, that's not a big deal. So these are literally just going to be like this. Why is that no bueno? Oh, wait. There we go, like that. Okay. No big deal. 7. Oh, that's what I was thinking. You would be correct. That's what I was trying to do. Yeah. I mean, a lot of these silly errors I would figure out eventually. But it's better to figure them out early. Shifted 6. The casting operator and shifting, that's a good question. Is it like a... How does it treat it mathematically under the hood? Does it treat it as like a power so you can multiply down? Does it do addition under the hood to move it across however many you ask? That's a good question. Well, I mean, like, I mean, yeah, but I mean, you know, like, the order of operations, you know, powers, exponents, multiply, divide, add, subtract, or whatever it is, whatever that order is. Or does shift, or you're saying shift literally... Oh, does it really? Well, I do recall there is the precedence, but I thought it followed like the same order that math does. Oh, cool. Yes, I've looked at. Oh, I've looked at this list before. Prefix increment. Is shift in here somewhere? bitwise shifting. Here we go. Yeah, so bitwise... There we go. So bitwise shifting is right here at number 7. So... Oh, whoops. Theoretically, what am I doing here? So... Oh, that's a cast. I don't know what it does with... Oh, a functional cast. Oh, am I looking at the wrong kind? C-style cast. There we go. So it will take precedence above my shift, actually. But, you know, I like being explicit, so it's fine. We'll do it manually. That's fine. We already know that I don't trust compilers. Two. Just one. And present is as is. Okay. Gotta go do that over here for this guy too. So. Seven. Six. Five. Four. Three. Two. One. Okay. That all makes good sense. Oh, the music? I have no idea. I just got this cool playlist playing from playing on YouTube. What's Frozen Synapse? Is that an artist? A movie, some kind? A game? Could be. I don't know. Is there maybe there's a... No, there's not like a title. Usually in the comment or in the description, it's like, you know, the timestamps for what the titles are, but no, it's just some background music I found on YouTube. Okay. So I can make one explicitly with all the data that I want. Oh, should this be an unsigned char? I should make that an unsigned char. Yes. Yes, I should. Because it's coming in as an unsigned char. Or we want to treat it as an unsigned char. Well, actually, that really doesn't matter because that's just free available space at the moment, actually. So we could treat it however we want, actually, but I don't see a need at the moment to treat it as assigned, so we'll just make it unsigned. Okay, so now I actually have to find memory locations to put into, or to save into these. So I decided to make it to where this isn't going to enforce a 4 kilobyte aligned location because the allocator should do that for me. Yeah. Let the allocator decide where to put a new page, or a new frame, actually. do I want to do this? So my dilemma here is, so the way that I did the other memory allocator, you can will turn into a 4 kilobyte address. Well, that's if I do this one. If I feed it, yeah, this if I make one explicitly right here with this constructor, it won't do anything special to make it a 4 kilobyte address, but this one will technically, yeah. So when I go find a memory location, in here, assert. Oh, I've never used assert statements before. That might be a good. No, yeah, it's like that doesn't come standard. I don't think you have to make that. Okay, assert. Because assert is just making a statement, and if the statement is false, it will trigger and do something. From what I understand, I've seen them used many times. They look kind of interesting, but I've never actually used one myself before. It wouldn't be that hard to make, would it? Yeah, and if that's false, you make it print something out. Oh, so it knows what line it's on? Is that a compiler thing then? Does something happens at compile time that it figures out? Oh, maybe that'd be a good place. Maybe that'd be a good place for like a const expression function. I was looking into those. They actually seem kind of cool. I think it was... I don't know if you were here for that discussion. No? Because then it could, like... Because that's evaluated at compile time. Or do compilers have a special, like... Oh, really? Do compilers just have a special, you know, a specialized way of allowing that? Use the file. We'll use the file line number of the const pointer function, and then Oh, I see. You're right. Do compilers just have a special dedicated means of setting that up then? Is that something I'll have to look into? Oh, really? The compiler will... Oh. Really? That's kind of cool. You can just use those variables whenever, and the compiler will pop them in for you? Okay, that's pretty cool. Let me look at that real quick. File macro. Yeah, so this just treats it like a char pointer. Oh gosh, I've got too many files open, or too many tabs. So this just treats it like a char pointer. That's really cool. I mean, that would make sense. Line is an int. Oh, wrong one. Line number macro. Okay, that's pretty cool. Yeah, there's no reason I should not put something like that in. Maybe I'll work on that next. That should go in next, definitely. Yeah. Yeah, there's no reason I shouldn't put something like that in. You know what? Here, even I'll do a to do assert that is for that's a good place to put that. Ah, so now I do have a good excuse to have, well, I mean, I can still use pound defines for those, I suppose. Yeah, I don't like having any active pound defines or compiler directives in a release build of something. So that's what some of the others were turning me on to const expression functions. That sounded more interesting because you can do something kind of similar. From the research I've done, I haven't really tried them yet, but I was looking at them. They sound kind of cool. Yeah, it sounds a little bit smarter and a little less risky because you're defining what the compiler's what to do in an instance. Yeah, but asserts an exception. Yeah, that makes sense. Yeah, because if you were to use line and whatever inside a const expression, it would take where the const expression is defined, not where you actually used it. Yeah, that makes perfect sense. I like it. Yeah, I need to. I'm open to learning new techniques that I've never used before, so I need to find a way to work some of that in. It's like someone before was talking about when I get to doing like the C standard library or whatever, if I want to compile for, user versus kernel space, you could use a const expression to decide that instead of compiler directives. And that idea sounds a little bit better to me. So when I come to that point, I'll really give it a try. Okay. Stupid earbuds. These earbuds don't fit my ears very well. Not very happy with them. Okay. So now, where was I? Yeah, so I got to make the actual allocator. So for the previous one where I made the minimum, there's a minimum size because you can ask for different sizes of stuff. This case, I don't think I need to do that because I can just make pages 4 kilobytes no matter what. So I'm thinking it might just go ahead and be wiser to allocate, to just section off a big chunk of memory for pages and just go ahead and chop it up into 4 kilobyte sections as is. And then there's really no need to ever delete a page or merge pages together. So if a page is, or a frame actually, this is frames actually. So if a frame is being used and then stops being used, that frame can stay there just ready to be reused again. There's no need to traverse a table to try to find if you have a spot that fits, because every spot's the same size. So the first free spot you find will be okay. And maybe this method might actually be better for the original method that I was going to try, and not the other way around. Well, right now I was thinking about just making them two separate, like, areas of memory. But yeah, I see what you're saying. I see what you're saying, though. Yeah, so you'd want, in every frame you section off, you'd want a space where you can malloc through and allocate memory for whatever process is using it. That does make sense. Well, see, the thing is, so like the allocation spot that I made now, that's kind of just for the kernel at the moment. So that's like the kernel's heap. And then so every frame could have a frame heap as well for whatever process is using it can just use. Yeah, but I was going to leave them separate. But the way that I was going to keep track of it originally, before coming up with the linked list idea, was I was going to use a bit field to just keep track of every char of every 8 bytes or every 8 bits that is used. But that was kind of silly because a Boolean and a character are the same size, so I would essentially be having the same size bit field to keep track of the same size of bytes, and that was kind of silly. But now, in this case, yeah, now because pages are so much bigger, it would be a lot easier to just have a bit field to keep track of which page is being used at the moment, because they're 4 whole kilobytes, which I think is the size I have for my heap right now is 4 kilobytes. If I were to pack the 8 bits into individual bytes, do you mean the one byte Boolean that is keeping track of every page, pack those down into 1 bit, actually, and do a true bit field instead of relying on Booleans, which are wasting 7 more bytes or 7 more bits? Yeah, I like your thinking. That could be a smarter way to do it. Okay. How am I going to do that? So, I guess I'll do it similar to the way I did memory, is where I just made a location. Yeah. That should be 4 I'm pretty sure that's 4 kilobytes right there. Is that? No. No, that's 16 kilobytes, isn't it? Okay, never mind. But there we go. So I guess I'll do something similar here, where I'll just define some constants. Go ahead and paging. I don't know. Always rename it later. basics. Okay, so yeah, I have. This just habit. Is it any better? Is there an advantage to doing it Pragma once as opposed to the way I do it? No. Yeah, this is the way I've always done it, so it's, I don't really think there's that big of a difference. Oh, really? Possibly. Okay, so what did I... Oh, Constance. That's what I named it. Okay, so... we want page... No, this is frames. Frame. I keep getting page and frame mixed up. So the frame is the actual physical spot in memory. And so that's what this is going to do. We're going to section off bits of physical memory into 4 kilobyte chunks. 4096. Frames will be 4 kilobytes each. I guess I can go ahead and... I guess I could go ahead and pick the... Would it be wise to go ahead and specify a maximum number of frames? Because that could then determine my size of memory that I need to allocate all those frames. I don't know. I can always go back and change this later. Like... trying to think. Oh, it's just... I mean, it's... I'm using this in the way that you might use pound defines. Why do you think that's confusing? That's kind of what I did for the first memory allocator. I didn't actually end up using eternal size, but whatever. Well, I guess I see what you're saying. I mean, oh. Because, I mean, I used it here, and then, where did I actually use it? Yeah, like here. I just treated them kind of like constants. You know? Yeah, you're right. You're right. Yeah, doesn't... I mean, don't enums kind of like... Maybe I'm thinking of the wrong language. Don't enums kind of like namespace it together a little bit too? Because then you'd have to do like... Because then you could do color, scope operator, red, that kind of thing. So it tells you like where it's coming from. Or what collection, what enum it's a part of. Because, I mean, if you did a color enum, couldn't you do, like, color red? That kind of thing, when you use it? I don't know. Maybe I'm off base. Enum class. Oh... Okay. Yeah, I'm off base. Yeah, you could. That's true. But kind of unnecessary. No, I see what you're saying, and I think you're right, actually. Number of frames. How many frames is a good number to start with? Gosh, can't type. Because, I mean, you can have normal semantics. No, you're right. Then again, I've never been very normal, but if you've watched me code for any amount of time, I'm sure. Approximately 1,000 frames before megabytes. Yeah, that's right. So, based on our definitions, we can have every page directory can have 1024 page tables in it, and each page table can have 1024 pages in it. So theoretically, every page table could be 4. Is that 4 kilobytes? Yeah, because every entry is 4 bytes, an integer, and you can have 1,000 of them. So every table can be up to 4 kilobytes, and every directory can be up to 4 kilobytes. That would make sense. Designed to fit in a page. Yeah, that make good sense. So theoretically, a page directory can hold information for up to 1,000 4 megabytes. That's 4 megabytes, isn't it? So 1,000 for the 4 megabytes times 1,000 gives you 4 gigabytes. Just designed to fit it. Okay. Is also where you get 4 gigabytes of address space. Yep. So, I mean, would it be off base to just take, like from a spot all the way to the end of memory as page allocation space? Because, like, I put my kernel heap at memory location 1 zeros. That's true. Yeah, you're right. But I mean, for now, like, maybe give it a gigabyte. Yeah, you're probably right. So I'll have to put it somewhere is the thing. So struggle to use 1 megabyte. You're probably right. I'm sure you're right. So I need to be smart about where I put it though. So this can be moved. So my kernel heap starts at this location, and I only allowed it, I'm pretty sure, to be up to 16 megabytes. Hang on one second. So 4 kilobytes times 1024, that'll get me to 4 megabytes? Because everyone's 1,000 difference, right? Yeah. Right, and that's one directory. Yeah, so one directory will get you to 4, can reference 4. No, that's not right. You can reference the whole 4 gig address space in one directory. Math's not working out for me right now. Duh. Yes, there's another layer between. So a frame can be 4 megabytes. A page table can hold. No, a frame can be 4 kilobytes. A page table can hold 4 megabytes of pages. A page directory can hold 4 megabytes of page tables, getting you to 4 gigabytes. So one page directory can get you all 4 gigabytes. Yes. So a page table can get you to 4 megabytes. So if I want to allow myself up to a gigabyte. Oh gosh, okay. If I want 4096 times 1024. That's megabytes. Yeah, you're right. 1024 times 1024 divided by 4. You're right. So that many bytes will get me to 1 gigabyte. Two six two 144. So that's 1 gigabyte worth of frames. Okay, that's reasonable. So now I gotta think of a good place to put it. This memory math is stretching my brain here. So in my linker file, see, I specified this is where the location of my kernel, well, at least of main. Well, no, that's the beginning. That's the beginning of my text section, I believe. Yeah. Place my text section, which is the code, at this physical address. So that's going to start that right there. So that's fine. And then the only other thing I specify is my memory location. Which is 16 kilobytes. Oh, I figured it out. Oh, I can just do. I can just go see what that is. So that. What is 16, 3, 8? Oh no, I want a programmer. 16, 3, 8, 4. In hex is 4,000. Oh, no, no. There we go. So that's going to go up to 0x00 4000, like that. So that's the end of my heap right there. Could just start it right after that. It might do me good to make like some memory layout struct or something where I can pick all the locations of these on the fly and it will do all the math for me. So if I want to change the location of one, it will automatically like math through and put everything where it needs to go. That might be wise. But anyway, so as long as I place it after this, well, I'm talking about like, yeah, at when building, like say, okay, I want my kernel heap here, I want my paging field to be right after that, and it just do the math through. So if I say I want my kernel heap to be this long, it'll just say, oh, okay, this long, and then your paging field's going to start right after that, so it'll do, this plus this plus this. It'll just do it all for you. So that'd be a good thing to do. So once I kind of figure out maybe, well, I mean, that's really the only, and that'd be pretty extendable too. Like if I wanted to add a new type of allocator, like a slab allocator, I could just kind of throw that in. Might be a good thing to do too. I should probably do that at some point. See if I can just get this working at a specific spot though. So I just said that 262144, that's equal to 40,000 in hex. That makes sense. So if I begin... That's 1 gig... Really? Wait, what did I just do? Hex 400. Wait, what? No, stop it. 40000 times. Oh, 10,000 bytes. Yeah, okay. Yeah, so 4 gigabytes is 10,000 bytes because that's a billion. That's a billion bytes. No, a billion bits. A gigabyte. No, wait a second. Gigabyte should be a billion bytes, shouldn't it? How does that math work out? Oh, because I was in hex. Yeah, that makes sense. So that's only a million now. I'm not crazy, am I? 4 gigabytes should be a billion bytes. If that's if 1 gigabyte 2622144. Yeah, 4 should be 1 million frames. Right, okay. Yeah, so 1 gigabyte should be roughly a billion. Oh, because those are... Oh, because frames are 4 kilobytes already. That's why my math's not working. Divided by 4096. That's not what I want. I'm trying to get back to a memory offset. Exactly. What am I trying to figure out? I'm trying to figure out what the hex offset's going to be, so I can say if I start it here, it'll end here. One second. So I got 4096 frames times 1024. That's 4 megabytes. And 4 megabytes, that's 1 page. Oh, that's 1 page table. Got it. Times 1024. That's 4 gigabytes. There we go. That's 1 gigabyte. Right there. So hex of 400,000. No. 1, 2, 3, 1, 2, 3, 40 million. Got it. Okay. So if I begin my heap, or my my paging field. Here, let me just include paging. So if I begin my paging field, just for the sake of example, at OX that. Wait, is that what my memory sizes are? 1, 2, 3, 4, 5, 6, 7, 8. There's actually 8 digits. And like that right there. Then it will end at 1, 2. Like that, right? That's 1 gigabyte. Oh, that makes sense too, because it's in hex. Yeah, so 4. So up to the 4 is the first gigabyte. Then that would be the second gigabyte. And then I think B would be the next one, and then F would be in the 4th gigabyte. Makes sense. Got it. Makes sense. So I could just start, for the sake of simplicity, I could just start my kernel or my paging field right at the first gigabyte and just go to the second gigabyte. Yeah. Okay. Hopefully I didn't bore you too much with that. So now, do I want to just go ahead and allocate that, allocate it away straight away? Ooh, I might have to go soon. Let me just go and get this set up. So, int pointer frame field. No, frame field's good. Right? Wait. One, 2, 3, 4, 5, 6, 7, 8. Yeah. 8 bits. Or 8, hex bits. Well, 8 bytes, sorry. The start of the frame field is at the 1 gig mark. 1 gig big. Yeah, so theoretically, I would want to say, I'd want a struct that I can say, okay, I want my kernel heap to be start at this location and be this size. Great. I want my frame field to start at this location and then I want my frame heap or my frame field to be this size, and then I want all these other memory structures to be of this certain size, and it will just go through and figure out where to place them adjacent to each other so they don't overlap. That'd be a wise thing to do, but I'm not doing that right now. So I did basically the same thing right here, right? So static. And then I want to do a So I need exactly that many bits to keep track of the bit to make the bit field. Divided by 4096. So yeah, so I need something that has exactly this many bits in it. So if I divide that by 8, so I need that many chars. If I divide that by 4 again, I need that many integers. I need something with that many integers, because that'll have enough bits to keep track of exactly 1 bit for every frame. Because then all I would have to do is multiply the index into that array times the size of my frame, and that put me right where I want to go. Yeah. Static unsigned int frame field bitmap. And how many was that? 8192. It doesn't actually matter how I allocate it though, because I'm just gonna be shifting bits in and out of it all the time. And bit shifting's pretty fast, so it won't be that big a deal to just start at the top and start shifting through until you find a 0. Maybe I should make a class for this too. Include unpacked page table entry. Well, actually, first I should just make something that can go find a frame for me. Can you return a void pointer? Yeah, you can. New frame. Or find new frame. Alright, so now I want to index into the... I guess I should go through and zero this thing out first. How do I have this doing before? Yeah. Is that what I really want to do, though? Do I want to treat that like an array? Yeah, I do. I want to allocate it all out. Oh, but I can treat the... I can just use the... I can just use the memory address. Frame, field, bitmap. Crap, do I want to treat this like as bytes? I can't do one big thing. Can I do the address? Or the reference to? No, that's not gonna work. Or one shifted I times. That's not integer underscore. That's not right. How did I do the... See, it's in VGA controller. See, I can only do this if I specified a type. Well, I specified a buffer right there, so I don't know. I want to allocate away all this. Can I dereference it? That's not what I want. That'll get me the beginning. Oh, this is how many integers I have anyway. Oh, this is just zeroing out, too. What am I doing? This is okay. I can just do this. Derp. That's silly. Zero out the whole bit field. Yeah, so that'll zero the whole thing out. How am I going to bit shift into that? Or pack it? Oh, I have an idea. So I can make it quicker, first of all, by saying for int I 0, I is less than 8192, I plus plus. I could just go through and see if there's any of these bit fields that don't already equal max int, then that means they're already taken. So if they don't equal max integer, then they must have a free spot. If frame field bitmap I does not already equal, then it must have a free spot. It must have a free spot available. So then oh, and then I could do a while loop. While this could be tricky. I have an idea though. So while frame field I is less than one, two, four, 8 is less than 8. O X O O. Wait. 8 O. So that'll check to see if the most significant bit is a 1 or a 0. So while the most significant bit is not a 0, essentially, because if the MSB is a 0, right? Is less than that. See if the MSB is a 0, yeah. Oh. Let's keep track of that, see, so we don't have to, so we don't accidentally destroy it. Because we gotta do some bit shifting here. Bit map copy. Bitmap copy equals wait, I don't actually have to destroy it. Index plus plus bitmap copy shift right 1. So that'll so as long as the MSB is 0. Oh, wait a second, I don't want that. I want to be greater than. Is not 0. So if it's greater than this 8, that means the MSB must be full. And so we want to scroll it and push it off the end until we get to one that is 0. So after we get out of this while loop, index should know how many bits in we scrolled here. Let's move these out here. Major index equals 0. int minor index equals 0. So this is minor index. So the major index would be kept track of by I, how many integers we've jumped across, and then the minor index will be how many bits into that int exactly it is. So yeah, so after this we have found, so this for loop will take us to a major index that has a free spot, and then the minor index will go through to find out which bit it is inside. So if we made it through here, we need to break. That'll put us back out here. So now, oh, we want to do major index equals I. And then we'll be outside the for loop. So now outside the for loop, major and minor index. Actually, let's set these to -1. Do I want to do that? Because I'm counting on this to... I guess I can make a... call this temp index, I suppose. And then, so minor index equals temp index. Okay, so after that, so we can make sure that if we found one, at least at -1, if they're not -1. That'd be a great place for an assert right there. Yeah. Okay. I actually have to go right now. That's the thing. But this is some pretty good progress, so I might actually stream some more later tonight. So, if anyone's interested, please stop on by again. I'm not going to check this in just yet, but there's my GitHub link for all this code. If you want to look at this code, feel free to check it out. And yeah, there's also links down below for the GitHub and YouTube and all that fun stuff. So, yeah. Hopefully I'll be back on in a couple of hours, though. And hopefully I will see you guys there. See you later.